To the untrained eye, computer code looks like an impenetrable wall of completely random text and cryptic symbols. But just like human speech, software development is split into dozens of distinct, highly specialized languages. No single language is universally perfect, each one was deliberately engineered to solve a very specific problem in tech history. From rendering the basic text on a web page to deploying automated smart contracts on decentralized blockchains. The choice of code dictates exactly how fast, secure, or beautiful a piece of modern technology will ultimately be. Today, we are breaking down the core world-running languages, how they operate, and the exact industries they keep alive. Before we dive into logic, we must cover the two foundational building blocks that construct literally every single website on Earth, HTML and CSS. First, HTML, or Hypertext Markup Language, is not actually a programming language, it is a markup language. Created by Tim Berners-Lee in 1993, HTML acts as the absolute skeleton of the web, dictating where text, images, and buttons structurally sit. But a skeleton is boring without a visual design, which is why Cascading Style Sheets, or CSS, was introduced in 1996. CSS acts as the skin and wardrobe, controlling the colors, layouts, typography, and responsive animations of that structure. Together, HTML and CSS completely run the digital marketing, web design, and front-end development industries, dictating how brands present themselves online. Moving from markup to pure logical programming, we find the most popular and fastest-growing language on Earth, Python. Created by developer Guido van Rossum in 1991, Python was explicitly built with one core philosophy: readability. Because of this minimalist design, Python strips away complex brackets and forces programmers to organize code using clean spacing. Today, this simplicity has made Python the absolute foundation for the modern artificial intelligence and data science industries. Tech giants use it to build generative AI tools, while Wall Street firms deploy it to run lightning-fast data analytics on market trends. While HTML is the skeleton and CSS is the skin, our next language acts as the functional brain of the web browser, JavaScript. Engineered by Brendan Eich in just 10 days in 1995, JavaScript was built to give flat web pages the power to react to human behavior instantly. Every time you see a live notification pop up, a scrolling map, or an animated graphic update automatically on a website, JavaScript is working. This versatility makes JavaScript the absolute ruler of the e-commerce and social media industries, keeping networks like Amazon, Netflix, and Meta highly interactive. If you like this video so far, don't forget to like and comment to let us know your favorite language to code in. If Python is a consumer vehicle and JavaScript is the highway, our next language is a high-performance Formula One race car. Developed in 1985, C++ was engineered to compile directly into raw machine code, giving developers absolute, uninhibited control over computer hardware. It forces programmers to manually manage memory allocations, offering unmatched execution speed and efficiency. Because of this raw power, C++ is the lifeblood of the gaming industry, powering engines like Unreal Engine, as well as aerospace engineering, where it controls flight safety systems. In the early 1990s, software developers faced a nightmare: code written for one computer chip wouldn't work on another. Sun Microsystems solved this in 1995 by releasing Java, built around the legendary slogan, "Write once, run anywhere." Java achieved this by introducing the Java Virtual Machine, a standardized software layer that runs on any device, isolating the code from the hardware. Walk into any global enterprise banking headquarters or logistics corporation, and you'll find Java. It keeps financial transaction networks incredibly stable and handles complex global shipping routes securely. Seeing the massive success of Java, tech giant Microsoft decided to engineer their own flagship competitor in the year 2000, C#. C# was built to combine the extreme power of C++ with the absolute visual ease and safety of Java, fully integrated into Microsoft's ecosystem. This versatility has made C# the absolute dominant language in indie game development via the world-famous Unity engine, as well as enterprise Windows software for massive corporate infrastructures. While older languages are highly capable, traditional memory management can still lead to catastrophic security exploits. To fix these vulnerabilities, Mozilla developed Rust, designed to offer the raw speed of C++ but with absolute, mathematical memory safety guaranteed. It achieves this through a strict compiler tool known as the borrow checker, which physically blocks insecure code from even compiling. Because a single glitch can expose millions of users, the cybersecurity and cloud infrastructure industries are migrating to Rust rapidly to build bulletproof server environments. As the digital world shifted toward decentralization, a completely new paradigm of code emerged to power programmable finance. Released in 2015 for the Ethereum network, Solidity was built specifically to create what are known as smart contracts. Today, Solidity completely dominates the decentralized finance and blockchain industries, securing hundreds of billions of dollars in crypto assets, NFTs, and global dApps. While Solidity revolutionized Web3, its architecture makes it notoriously vulnerable to smart contract hacks and multi-million-dollar exploits. To fix these structural flaws, engineers at Meta originally designed a radical new asset-oriented language called Move. Move introduces a concept where digital tokens are treated as literal, physical resources that cannot be accidentally duplicated, dropped, or double-spent. Move has quickly become the premium foundation for next-generation blockchains like Aptos and Sway, built entirely to power high-speed, secure global crypto transactions. Ultimately, understanding coding languages isn't about finding one single undisputed winner. It's about choosing the absolute correct tool for the specific architectural job you are trying to build. Which of these powerful tech frameworks are you planning to learn or master next on your journey? Make sure to drop a like and subscribe to explore more incredible tech and code breakdowns with us here at The World Facts.